Okay. So
Are we gonna watch the entire 70?
no, it's too long to do the whole thing. Although this is a really good video, so I will upload this link to Google Classroom if you want to watch the whole thing. But yeah, there's this really good Vsauce video called Spinning. Explains a lot of these rotational concepts. So near the beginning, one of these talks about is centripetal force, which you guys learned a long time ago in this class. You guys did a whole lot about it. But it talks about some other phenomena like gyroscope. Like why would a gyroscope stand up? Which is a question I threw at you guys yesterday. I said, I want you guys to mull over this for about a day. So I broke out a gyroscope yesterday. Spun it. Why is it that when it's spinning, it'll stay upright, but when it's not spinning, it'll fall down? Same thing with a coin. Put a coin on its edge, right? And then give it a flick and start spinning, it'll stay up. Okay. Also, that bicycle wheel back there, right? You guys got your hands on that bicycle wheel yesterday. It feels really weird when it's spinning. So what's going on there? Okay. Something to do with angular momentum, right? So let me flip to the part of the explanation I care about here. Yeah. Here, you guys remember this? Right? You go around a curve, there's actually a centripetal force that pulls you in. There's no such thing as a centrifugal force pushing you out, although if you're in a rotating frame reference, it feels like that. Okay, here we go. Here. So I've got this paused on frame. See this this orange rolly ball? It's just gonna be rolling in a straight line. That red vector could be the velocity vector, right, at the moment. They see how from below he's about to bam, he's about to hit it up from below. So he's going to knock it straight upward. Now, what's that ball going to do when it's rolling to the right and bam, now it's been hit upward? It's going to go kind of up to the right. Do you guys think? Yeah, that would make sense. That's exactly what it's going to do. It's going to follow that gray arrow vector right there. Right? What if you slow the ball down? So now it's not going as fast. Oh, well, it's going to follow like that, right? So that's okay for a single point mass, right? But that would do that. Right, now let's look at a point mass, say like in rotation around the Earth. Right, so it's going to be a similar idea. Let me scoot ahead a little bit here. Okay, so this satellite's already moving, say to the right, like to the east, to the right. What if you hit it, bam, like towards the south? Is it going to stop what it's doing and just start going straight south? No, it's going to keep going east, but also go south at the same time. It's going to follow kind of like this direction down here, like kind of southeast. Okay, I think that's what it would do. Okay. So then it's going to set up a new orbit. It's going to follow that blue orbit. So it was following the green orbit, and then right at this point, you bam, hit it straight down, and now it follows the blue orbit, which means that, yeah, so it doesn't tilt that way. It actually tilts like that way, which is 90 degrees ahead of where the force was applied. Okay? Now, you could take this single satellite, the single point mass, and you can have like a billion satellites going all the way around. And that would be like a gyroscope, wouldn't it? Okay? So if the gyroscope isn't spinning, then it starts to fall over and just like bam, just falls over. So whatever, right? But if it is rotating, then when it starts to fall over, there's a component of its weight that's pulling in that direction, but that's going to manifest itself in the motion 90 degrees ahead in terms of the rotation. So then it'll actually start to process around. Okay, so it actually won't fall. So there goes a little bit of an explanation for gyroscope. If you want to watch the whole thing, I'll upload that video later. Okay. Also upload this link. This is a fun one. Tom Scott video. He goes inside this rotating room. Can I get the room somewhere? Well, right. Anyway, he's inside a rotating room, right? So that room's like rotating. Right? Now, hard to tell just by the camera, right? But you see he's like leaning at an angle, but he feels like he's upright, right? So they do all this fun physics of like being in. Oh, there it is. There's the rotating room. Did I skip it? Okay, so anyway, the thing's rotating. Right, so let's go inside this thing. At some point, they start throwing the ball around. They do lots of little fun experiments, but at least get to the ball. Oh, did I show this to you guys? 1 point. All right. Yeah, wasn't sure if I had.
Little curves in the air because it's moving straight.
Right. Yeah, the ball. The ball's only ever going straight, but in this rotating vector reference, yeah, it looks like it curves off, right? It's like a Coriolis effect type thing, right? Okay. And then let's see if they. All right. So if it goes off at an angle. Then you can catch it. All right, so that's fun. All right, let's go back over to back over here.